everybody. Today we're going to be learning about section 7.5, which is about indoor air pollutants. Learning objective for today is that you can identify indoor air pollutants, and the essential knowledge that you're going to gain is basically all the different types of air pollutants and why they are not good. So we're going to first start by talking about developing versus developed countries and the typical air pollutants that we get in these different types of countries. So starting out, a reminder that developing nations use more subsistence fuels, such as like wood, manure, charcoal, just biomass that are going to be burned for heating and for cooking. Now, these biomass fuels release carbon monoxide, particulate matter, NOx, and VOx. And often the problem with these in developing countries is that these are being burned indoors. And so you're going to have poor ventilation, which is going to lead to higher concentrations of these air pollutants. Now, there's an estimated 3 billion people who globally cook with subsistence fuels, which we have an estimated 3.5 to 4.3 million people who die annually from causes that can be traced back to this form of cooking. Things like if you die of an asthma attack that was caused by particulate matter that was released from the fire, then you could tie that back to saying that this cooking with the subsistence fuels is what's causing it. So we're seeing a large number of people dying annually from this. Now, in developed nations, we use more commercial fuels like coal, oil, natural gas to supply our utilities. These are typically going to be burned in closed, well-ventilated furnaces and stoves. So we aren't necessarily going to have the same problems on as big of a scale as what the developing nations are getting from their subsistence fuels. However, what we end up having is major air pollutants in developed nations come from chemicals in the products. So adhesives in furniture, cleaning supplies, insulation, lead paint, things like that. And so in the developing nations, it's going to be more from the subsistence fuels. In developed nations, it's going to be more from like all the products that we have filling our houses. So the first couple of things that we're going to talk about is particulate matter. We're specifically going to focus a little bit on asbestos too. So particulate matter, are going to be a very common indoor air pollutant. So things like smoke, either from indoor biomass combustion, maybe you have a wood fireplace, or smoke from like cigarettes. You also have a lot of dust inside houses, which hopefully you are all kind of familiar with dust, so I'm not going to go too much into that one. But I am going to talk a bit more about asbestos because that is kind of a nasty one and you might not be as familiar with it. So asbestos is a long silicate particle that used to be used in a lot of not insulation, but not just insulation. It was in like floor tiles, it was in roofing, it was in shingles. And that's because it was a fire retardant. It did not catch on fire as well as some other things. And so it was used tons in houses because we didn't want houses to be burning down. The only problem is after we started mass using them, a couple decades later, we started realizing that asbestos actually causes lung cancer. And so now all of a sudden we have it in a lot of houses, but we changed the regulations. So asbestos was phased out. New construction is not made with asbestos, but it does remain in older homes. So any home that's older than like the 1960s, there is a risk that asbestos could be in it. Now, luckily with asbestos, you may have gone into old buildings and seen signs that say there's asbestos and maybe you're worried about it. Now, actually, asbestos is not really dangerous at all until it's disturbed. So like if this insulation is just chilling in the attic and not being opened up, not going anywhere, it's going to be fine. But if you're going and you're like roughing around getting something in your attic and the insulation's getting kicked up, that's where it can be breathed in. That is where it can enter the respiratory tract. And then we're having the problems that come from it. Now, asbestos, this is why you have to pay to get asbestos removed. It should be removed by trained professionals that have proper respiratory equipment. They have a whole setup with like ventilation and they block off access to other places. And it has to be done properly because the risk of asbestos is so concerning for lung cancer. So as I said, though, particulate matter, we're including all sorts of things. I'm just going a little bit more in depth because I kind of assume that you know what dust and smoke are, but maybe asbestos is one that you didn't know as much about, which is why I covered it a little bit more in these. So now we're going to talk about carbon monoxide, which is different than carbon dioxide. This is just CO. So carbon monoxide is going to be produced by incomplete combustion of basically any fuel. And incomplete combustion is where we are having it burned, but not all the fuel is actually getting burned because we have low oxygen levels or we have lower temperatures. And so when we have not enough oxygen, you're going to having carbon monoxide is going to be produced. Now, carbon monoxide is super dangerous. It is an asphyxiant. The reason it is an asphyxiant, technically you asphyxiate, and that is because it causes suffocation basically through your blood from what's known as carbon monoxide poisoning. So what happens is this carbon monoxide binds to the hemoglobin in your blood, which means that your blood can no longer carry oxygen. And when you don't have oxygen, you're going to suffocate. So the specific form of suffocation via the blood is known as asphyxiation. And so what is going to happen when you have carbon monoxide is you can die from it. It's actually a very dangerous one. And one of the things that's also a problem is that it's odorless and colorless. It is hard to detect. And so it's hard to detect, and it can be lethal to humans in high concentrations, especially with poor ventilation. Carbon monoxide is why you should not run your car in a closed garage because you will get carbon monoxide poisoning and you can die if it is not ventilated. Now, in developed nations, carbon monoxide is going to be released into homes by malfunctioning natural gas furnace ventilation. It is going to be when something's wrong with your natural gas furnace. Now, we do have carbon monoxide detectors that there are laws being changed that carbon monoxide detectors are now required in all newer homes. But they're similar to a smoke detector. They just detect carbon monoxide because, again, carbon monoxide is odorless and colorless because so it's hard to detect, which is why the carbon monoxide detectors are very important, especially if you have a natural gas furnace in your house. Now, in developing nations, this carbon monoxide is going to be emitted from indoor biomass combustion for heating and cooking. So again, if there's low oxygen levels or the temperatures don't get hot enough, then carbon monoxide can actually be released from just your regular burning fires. Now we also have VOCs, the volatile organic compounds. And VOCs are going to be found in chemicals that are used in a variety of home products that can easily vaporize. They can enter the air, irritate the eyes, the lungs, cause the irritation in your actual lung bronchioles. And these are going to be found in tons of things, such as adhesives of sealants. So chemicals that are used to glue carpet down or hold furniture together or seal panels. If you kind of know what that new carpet smell is, it is actually caused by formaldehyde, which is a chemical that is going to be found in the carpet glues and then also in particle board. And so that new carpet smell is actually a VOCs. Also common household cleaners and deodorizers such as Febreze, those have VOCs in them. Plastics and fabrics can also both release VOCs themselves, or they can produce VOCs from the production of these plastics and fabrics. And so that is going to be some common places where we're going to get them within our houses. So now we have radon gas, which luckily radon gas in our area is not as huge of a concern. There are areas where they have a lot more of it, but it's important for you to be aware of. So radon gas is radioactive gas, specifically radon 222, and it's going to be released by the decay of uranium that is naturally found in rocks underground. Especially granite is going to be having their uranium in it. So the way that radon gas usually gets into the home is going to be through cracks in the foundation and then disperses up from the basement and foundation through the home. So let's say this is some granite rock. It's got uranium. It's going to decay into radium, which is then going to decay into radon, and radon's what's potentially going to be able to get up into the house through the cracks in the foundation. It can also seep into groundwater sources and enter the body through drinking water. Now, radon gas is the second leading cause of lung cancer after smoking. So it's actually like pretty prevalent and it's a big concern. So the EPA recommends testing homes with airborne radon monitors. You can have companies come in and test your radon. You can actually buy things to do it yourself. You can get them with home inspections, but the EPA recommends getting this tested to be aware if this is a problem in your home. Now, if it is going to be a problem, some of the ways that you can prevent it is sealing cracks in the foundation to prevent it from entering, and then also just increasing ventilation within the home to disperse it if it is detected. Now, some ones that are very common in the home are going to be dust and mold. And these are going to be natural indoor air pollutants that can worsen asthma, bronchitis, COPD, and emphysema. Dust is something that just settles in homes naturally. You probably all have dust within your homes. We have dust within our school. And dust is going to be disturbed by movement. It's then going to enter the air and it can get into the respiratory tract. Now, mold, which is super duper common here in Western Washington because we have a lot of moisture and mold loves moisture. So mold is going to develop in areas that are dark and damp and aren't well ventilated. Which common areas can be like under the sinks, in the showers, behind panels in the walls, and the ceiling. Honestly, here in Western Washington, mold will sometimes just form on my windows because I feel like mold is like basically everywhere here, but it's very common and it's going to be developing again in kind of these damp, dark areas. So, sorry, this is a picture of dust, a little bit. Nope, never mind. Sorry. That's dust up there. This is black mold. When you peel up this laminate, and so water was probably getting under this flooring. So when you peel it up, you're then seeing all of this mold there. So black mold is one that is especially dangerous, the one right here in this picture. And that's going to be because black mold releases spores into the air, and these spores can be especially harmful to the respiratory system. Now, mold can be removed by physically cleaning mold out. Usually you have to use bleach in order to actually kill it and clean it out. And then also fixing the water leak or ventilation issue that led to the mold forming. It's really important if you have mold forming to not just clean it, but to figure out why it is forming there, and then to do everything you can to prevent that so that you don't get this black mold, you don't get these spores in the air and having it be something that can lead to further problems. Now we're going to talk about lead. Lead is found in all old homes. Basically, any home that was painted before the 80s is going to have lead in it because lead used to be in paint. Now, the EPA banned lead paint in 1978. However, if you live in a home that was existing or painted before those times, then you're going to have layers of paint that do have lead in them. And so you have to be careful because paint can chip off the walls and windows. Small children eat random things. Sometimes little babies will start chewing on windowsills. So if you have lead paint, that is going to be a problem. Additionally, if you're just getting little flakes of it, then it can be made into dust and then you can end up inhaling it. Additionally, not only can lead be found in paint, but lead can actually also be in water pipes, especially old water pipes used to be made of lead, and it can be released into the drinking water. If you've heard about Flint, Michigan, this is something that happened in their drinking water. They added some new chemicals, which ended up corroding the lead pipes, which ended up making the water poisonous. People in Flint got poisonous. It was super sketchy because the government, like local government, tried to quiet it up and hide it. So Flint's just like a very sketchy instance of it. But lead pipes do exist and they can cause problems. Most cities are slowly replacing all of their lead pipes, but every once in a while you get it to where levels can get too high and then cities will tell you not to drink. That actually happened here in Western Washington 7 or 8 years ago. where they told people until they could get everything tested to not drink the water for a little while. It is less common than lead paint, but it is something that's common enough that cities do have to deal with getting those replaced. Now, the reason that lead is a big problem is because it damages the central nervous system, especially of children, because they're a smaller size and their brain is still developing. So, like babies eating lead paint is actually very much a problem, not as problematic if like you and I inhale some lead dust, but it is still a neurotoxin, so none of us should be having lead, but it's especially bad for children. So one of the things to help with this is to remove any lead paint that you might have in a home by stripping it and then replacing it with a non-lead based paint. And then the lead water pipes can be replaced by cities with copper pipes. Also within your house, if you have lead pipes, you can replace them with copper pipes. So this is going to be your practice FRQ for 7.5. I want you to practice the suggested skill of explaining patterns and trends in data to draw conclusions. So I want you to look at this graph right here. Now, make sure that you're paying attention to what the different parts of the graph represent. Blue is going to be the number of children tested. Red is going to be the confirmed blood lead levels that are above 10 micrograms. And then the green is going to be the blood lead levels that are between 5 to 9 micrograms. So what I want you to do is to explain a cause for the trend in the confirmed blood lead levels above 10 micrograms as a percentage of children tested from 1997 to 2015. And that is going to be your practice FRQ for 7.5, and those are your notes on 7.5.